In this video, we are going to break down one of the most fundamental concepts in machine learning and optimization called the gradient descent. When you're training a neural network or fitting a line through data, gradient descent is the go-to algorithm. And what is it really doing behind the scenes is what we're going to look at. We first build the intuition visually and conceptually, and then dive into the code, writing it from scratch. So imagine you're standing on a smooth hill, and the goal is to get to the bottom of it. That's essentially what optimization is. We are trying to find the minimum value of a function. So let us take a simple function, f of x is equals to x squared. We already know that the minimum value of this function is zero, at x is equals to 0. But what if we didn't know this? We need to write an algorithm which takes us closer to this value. And one such algorithm is gradient descent. So the whole point of gradient descent is that you can look at the slope of a function and find the direction of the steepest descent of that function. So if the slope of the function, if the slope of the function is if the slope of the function is positive, you move towards the left. Like you move the values of x towards the left. And if the slope is negative, then you move x towards the right. So essentially, gradient is equal, like is like slope is called gradient. So descending the like minimizing the value of x, like finding the value of f of x such that it is minimum. Using this slope is called gradient descent. So for this, we'll have an equation called if x new is equals to x old minus alpha of this gradient. So what necessarily is alpha? Alpha defines the steps we are going to take towards finding the least or minimum value to get a final solution. And how do we calculate this gradient? So gradient is the derivative of the function we're trying to minimize. So if f of x is equals to x squared is the function we are trying to minimize, then gradient is f dash of x, which is equal to 2x. So we will plug in this value in gradient, and this is the learning rate, as discussed earlier, is the steps we are taking towards the minimization. So, um, so if you look at the whole idea of learning rate, if you take two small steps, um, you might like take forever to reach the bottom of the hill. And again, if you take too huge of a step, you might converge or overshoot, or even worse, completely diverge from the function. So finding a good learning rate is the key to optimizing something. So, but what does this gradient descent account in machine learning? So the whole idea of machine learning follows like if we get X futures, these are the futures we are getting, and we need to get an output Y out of it. So we need to find a linear combination of this X futures which maps to Y. So initially there will be some weights and combinations which correlate with X and Y. But at the end, we have to test it out. Like we have to test many combinations of X and many combinations of the weights, like many combinations of the weights to find the Y, which like to find the ideal combination, which gives us the actual, like the most predictable Y. So for this, we try to minimize the loss we get. So the loss in the sense, if y predicted is denoted by this, and this is the actual y. The difference between this is what we'll be minimizing, or this will be the f of x for our gradient function here, and we have to try to minimize this function and adjust the weights accordingly, so that at the end of the day we get the actual result, like the actual linear combination, which gives us y from x. So this is how gradient descent is used in machine learning. Now let us do a small calculation to check how gradient descent works. So as we discussed, as we taken earlier, let's take f of x is equals to x square, and f dash of x is equals to 2x. Now necessarily we have to minimize this function. So, and let's assume we have an alpha of 0.01. So how do we minimize this function? So first, let's start with a starting variable. Let's assume that x is equals to somewhere around 3. Or for convenience, let's assume that x is somewhere around 10. So we know that the minimum value for f of x is equals to x square is at x is equals to 0. So how do we go from x is equals to 10 to x is equals to 0 is what we're going to see. So let us construct a small table here. X, the value of f of x, f dash of x, the value of f of x, and the value of x new. So initially, when x is equals to 10, the value of f of x is equals to 100, and the value of f dash of x is equals to 20. And then since the learning rate is 0.01, 0.01 into 20, which is equal to 2. Now we have to subtract this from 10. X old minus alpha into f of f dash of x. So this is our equation for x new. So 10 minus 2 is equals to 8. So we'll substitute 8 here. This is step 1 or iteration 1. Now in step 2, our x old will become 8, and f of x will become 64, and f dash of x will be 16, and x new will be um, um, 8 minus 1.6, which is necessarily 6.4. So we can see that the value of x keeps on decreasing as it goes. So this is how we calculate till the point we reach a saturation in this descent. So this is how gradient descent works on paper. So now let's look at a code to understand it better. So let us take the same example on code to understand like how gradient descent works better. Assume we have a function which maps to uh, and we have another function defining the gradient of this function. Now let's assume x is equals to 10, and alpha is equals to 0.1, and steps is equals to 100. Now, um, let's let's write a loop for I in range of steps. So what we're necessarily doing here is we're trying to minimize the function f of x, as we discussed from using the formula. So we have a fixed amount of steps, 100. So we're going to iterate to each step and check how each step minimizes the function. So x will be x minus alpha into of x. And let's print value of x at each step. So now let's run this code. So for because if you see the step, so if you see the output of this code, you can see that as the steps goes on, the value of x keeps on decreasing, and at a time it got stagnant at zeros. And as it goes on, the value of x kept on decreasing. But if you can observe, these all values are very, very much negligible to zero. So there's a constant point of x. So this constant point is called like this. At this constant point, we can say that the function has reached its local minima. So this is how gradient descent works in minimizing functions. So essentially, we use the loss functions instead of functions like x square or something in machine learning algorithms, and we try to minimize the loss so that our weights and our measure like our linear combinations give the best predicted y. So this is how gradient descent helps machine learning algorithms perform. Thank you.